Hey guys, today we're talking about properties of logs. Now, you might be thinking logs from like trees. So they're woody, they're barky, they burn really well, they hurt when they fall on your head. No, not those logs. Although those are probably true. We're talking about logarithms. And remember, logarithms are powers that you raise a base to in order to generate another number. Say that with me, just so you remember. They are powers you raise a base to generate another number. One more time. Logarithms are powers that you raise a base to in order to generate another number. And they have properties. And we can use those properties to help manipulate some functions and some equations for solving math problems. So our first property here is pretty intuitive. It says log base b of b is equal to 1. In other words, the power I raise b to in order to get b is 1. In fact, anything to the first power is just itself. So I could say log base 15 of 15, and guess what? That's going to be equal to 1. All right, our next property says log base b of 1 is equal to 0. In other words, b to the 0 power is equal to 1. And this is true no matter what your base is. So, for example, I could have said log of base 150 of 1 is going to equal 0. In other words, 150 to the 0 power is equal to 1. And that's true about any number. Any number to the 0 power is going to generate 1. All right, let's take a look at some of these other properties. The first one is this product of logarithm property. And it simply states that the log of base b of a product m times n is equal to log base b of m plus log base b of n. Now, let's write down an example. I'm going to say that the log base 2 of 32. Now, you probably know the answer to this already because you're really smart and you have a great math teacher. But we're going to just kind of separate 32 into a product of 8 times 4 to show you that this property really works. So think of 32 as 4 times 8. Well, log base 2 of 4 plus log base 2 of 8 would be my result then if I'm looking at this product property of logarithms. So let's work this out. What power do I raise 2 to in order to get 4? Well, this guy here is going to simplify to 2. And the next one says what power do I raise 2 to in order to get 8? Well, 2 cubed is going to generate 8. So 2 plus 3 would result in 5, which is probably what you came up with when we first looked at this problem and said, what power do I raise 2 to in order to get 32? You would have said 5. Okay, now let's take a look at one more problem here using this product property, the log of some scientific number, such as 5.6 times 10 to the negative 7. Remember, this is a really small number. That's like decimal point, and then 6 zeros, and then 5, 6. So if I want to take this, I can see that this is a product here, and I can actually rewrite this as just simply log of 5.6 plus log of 10 to the negative 7. And since I know a few things about logarithms, I can quickly calculate that, and it makes it a little bit easier for me to see what's going on there. All right, let's take a look at our next example. Our next example is the quotient property of logs. And it simply says this: log base b of some quotient or some fraction is equal to log base b of that numerator minus log base b of that denominator. So again, let's just do an example here, and we'll say log base 2 of, and let's go with 32 over 4. And again, you might be thinking to yourself, well, this is easy. 32 divided by 4 is 8. This should simplify to 3. All right, well, let's use our log property that we know and write it out. Log base 2 of 32 minus log base 2 of 4. So again, the power I raised 2 to in order to get 32 should be 5 minus 2. And as a result, this will give me 3, which I would have come to if I just had done 32 divided by 4, which is 8. Oops, log base 2 of 8, and you know that to be 3 as well. So you see that these properties hold true.